Maybe we're on page 13. I know that we are. I'm trying to get there. God bless you. Okay, here we go. So this is lesson 4.2, part 2. So we're still dealing with rational equations, but now we're going to use applications. So basically word problems. Whenever you see that word applications, that means you're going to apply what you know, probably in a word problem. So the first type of word problems that we're going to do are going to involve distance. And the formula for distance is D equals R times R times T, where distance is your rate and time. So if you think about like the speed on the highway, what is the speed on 70? Is it like 45, 50? What's this main road that runs through here? Like 70. Yeah. What is the speed limit on that? It's 45. Okay. So if I drive for 2 hours on that road and I follow the speed limit, my time is 2, my rate is 45. What is my distance? 45 times 2 is what? 90. Yeah, my distance would be 90. Now, what if I know that my distance is 90 and I drove for 2 hours? Could that tell me what my rate is? Yes. What if my distance is 90 and I was driving for 45 at a rate of 45? 90 divided by 45 tells me that I traveled for 2 hours. So all this formula box is showing you is that D equals R times T can be written to solve for the rate or for the time. That's all that box is telling you. Okay, does everybody get that? All right. So upstream, downstream. Who's ever gone canoeing before? It's much easier to canoe downstream with the current than it is to canoe upstream against the current, right? Okay. So Reuben went canoeing on the Neuse River last Saturday. He traveled 20 miles downstream, and then he turned around and traveled the same 20 miles upstream. Notice in the table, my distance for both the traveling downstream and upstream is 20 because like I went there, and then I turned around and came back, same distance. The total trip took him 7 hours. If the canoe travels 8 miles per hour, that's the speed of the canoe in still water. What is the speed of the current? So notice when I'm traveling with the current, when I'm going downstream, I'm going to add the speed of the water. But when I'm traveling upstream against the current, I'm going to subtract the speed of the water. Does that make sense? Okay. So we just have to write an expression for T1 in terms of distance and rate, meaning we're going to solve for T1. Well, I know that if I'm solving for T, the formula up top says that T equals D divided by R. Okay. So if I wanted the formula for T1, that's the first time right here, I would take my distance, which is 20. That's my first trip, divided by 8 plus C. Does everyone see how I use the table to get that information? Yes or no? Okay. So now it says we're going to do the same thing. We're going to write an expression for T2 in terms of distance and rate. So now I'm looking at the second trip number 2 for the time. So T2 equals, well, I traveled the same distance, 20, but my rate this time was 8 minus C. Okay. And then in the word problem, it said that the total time going downstream and upstream took 7 hours. So that means that T1 plus T2 equals 7. Are you guys with me on that? Okay. So we're going to use no, Zach, yes or no? Because I thought I saw you shake your head no. So we're going to use the expression. We're going to write an equation, but we're going to replace the expression for T1 into the T1 spot. And we're going to replace the expression for T2. We're going to use substitution and try and just write an equation. So let's see. T1, which is 20 divided by 8 plus C, plus the distance of 20 divided by 8 minus C equals 7. And that's all it's asking us to do. Just write an equation. Okay? And I think we've done that. Something equals something. And it asks us to write a rational equation, or it says, hey, guess what? You just wrote a rational equation. Why do you think this is called a rational equation? Any ideas? What does the word rational relate to? Think about rational numbers. Rational numbers do have fractions and decimals, right? So the definition of a rational number, when you guys learned about rational numbers, is that it's any number that can be written as a fraction. So if we have a rational equation, this means any equation that has a what in the denominator? Are you guys awake? Hello? Look in your denominator. What is unique about those denominators? What is something that's different? And they have a variable. Yes. So a rational equation is any equation with variables in the denominator. And I'm just going to remind you that the word rational, it pertains to fractions, right? It pertains, relates, I don't know how you want to say it, means fractions. Okay. So a rational equation is any equation that has a variable in the denominator. Questions on that? Okay, flip flop. All right, cool. Now look at that. I think that we're going to take the equation that we just wrote about my canoe trip and we're going to solve it. Okay. So the first thing I'm going to do is I'm just going to put this whole number 7 over 1 so you can see that it has a denominator of 1 because that might help your brain think about this. We're looking for the least common denominator. We're trying to clear the fractions. So what is the least common denominator, or what number can I multiply every term by, both sides of my equation by, that would allow me to clear the denominators? What are my factors in the first denominator? If you look in the first denominator, what's the factor? 8 plus c. Okay. So if I multiply both sides of the equation by 8 plus c, is that going to get rid of all of the fractions? No. Why not? So I would be stuck with the 8 minus c. So I have to multiply both sides of the equation by 8 plus c times 8 minus c. Does that make sense? And we're going to put it over 1. Put it over 1. And let's cross reduce. So if I multiply this first fraction, first term in my equation, 20 over 8 plus c, by 8 plus c times the quantity 8 minus c, notice that I can cancel out both of those. And that leaves me with 20 times the quantity of 8 minus c. Are we good with that? Okay. So now I am going to multiply the second fraction, the second term. Same thing. So when I take 20 over 8 minus c, and I multiply it by the product of 8 plus c times 8 minus c, notice I can cancel out the 8 minus c's. So that leaves me with plus 20 over, or 20 times 8 plus c. And then is there anything that I can cross off for that last term? No. So it's just going to be 7 times the quantity 8 plus c times 8 minus c. So here where it asks for your least common denominator, I'm going to write 8 plus c times 8 minus c. So now I need to do some what? I have to distribute and I have to FOIL over here. No voodoo math. I have to distribute and FOIL. So let's see, 20 times 8. Well, 2 times 8 is 16, so 20 times 8 is 160. 20 times negative c is negative 20c. Plus 20 times 8, well, that's a positive 160. And 20 times a positive c is a positive 20c. And on the left side, or sorry, on the right side, I have 7 times. Let's FOIL this out. 8 times 8 is 64. This is going to give me a positive 8c and a negative 8c. Can you guys see that? Let me do it this way. I'm putting it over here because I know I'm writing on top of the words. Positive c times 8 gives me 8c. 8 times a negative c gives me a negative 8c. What do those two middle terms do to each other? They cancel each other out because what kind of factors are these? It begins with a c. We said it a couple of times. I don't know, probably only 50 in this class. 1 point extra credit if you can tell me what it is. Those two factors are opposites. And we use them to multiply to get out the middle terms. Nope. Conjugates. +1 bonus. Got it. +1. I'll put that on your quiz. Maddie. +1. Good job. They're conjugates. And that's why we use conjugates, because we multiply out the middle term. So when I FOIL this out, I just have 64 plus c squared. Minus c squared. Thank you. And I have to multiply by 7. I have to multiply through by 7. So I'm going to kind of do a couple of things. I'm going to cancel out here. So that 160 plus 160 is 320 equals 7 times 64 is, calculator bunny, go. 448 minus 7c squared. How in the heck are we going to solve that? Say that again. Make it equal to 0. So I'm going to add 7c squared to both sides. And I'm also going to subtract 448 from both sides. So when I do that, I get this nice positive 7c squared. What is 320 minus 448? Minus 128 equals 0. Is that right? Okay. So is 128 divisible by 7? It's not. So we can't solve it by factoring. So what if we move that 128 back over to the other side and we write it as 7c squared equals a positive 128. And I just divide both sides by 7. So I really have c squared equals 128 over 7. Do you guys see that? That's really what I have. How would I solve for c? The speed of the current. What do I have to do to both sides to get rid of that c squared? Square root. So take the square root of both sides. So in your calculator, you're going to hit the square root button, parenthesis 128 divided by 7. Close your parenthesis. And it's going to tell you that c is about what value? I think I did 2 decimal places. 4.28. 4.28. I said miles. That's the speed of that's the rate of the current. Okay. So that's step number 4. We've solved the equation. I know that there's not a whole lot of spot here, so I scanned my notes and I put them in Canvas. I'm going to still do this whole verify thing because I think it's important for you to understand. So it says verify your answers, make sure that they're reasonable. So remember that the trip was 20 divided by 8 plus c, which is 4.28. And the other expression that we used was 20 divided by 8 minus 4.28. This one is the traveling downstream. This one is the travel upstream. Someone give me those two values. 20 divided by the quantity of 8 plus 4.28. because we just need to verify to make sure that we're. So this one is 6.78. Oh, 6.78. Okay, what'd you get for the minus one? I disagree. Here's what I want you to do. Listen, Will, you have to take the number 20 and you divide it by parenthesis 8 plus, or just divide it by 12.28. Because that's what 8 plus 4.28 is. 12.28. Yeah, 1.63. And then 20 divided by, this becomes 3.72. 20 divided by 3.72 is what? We'll say 5.37 for joyous purposes. What was the total time of that trip? So is 1.63 plus 5.37 7 hours? Because if it is, then our answers make sense. You should be paying attention to this. This is how you verify. Is it? Yeah, it is. So this is actually step number 5, the whole verify. We have verified that our answer is not crap. Because sometimes you guys get an answer and you put it down and I'm like, where did this come from? And you're like, that's what the calculator said. And I'm like, well, did you think about that? Does it even make sense? Oh, no. So this is us like proving that our answer makes sense. Okay. All right. Now we're going to do a similar problem. Lamar, you with me? Okay. Mackenzie, you with me? All right. So a small jet has an airspeed of 350 miles per hour. That's my speed in still air. During one day's flights, the pilot noted that the plane could fly 124 miles with a tailwind. Tailwind is pushing you. It's the wind that's coming from your tail, your booty, and pushing you that way. But it took the same time to fly only 116 miles when he was going against the wind. Okay. So here's what I want to do. Tell me the first trip when I had a tailwind, what was my distance? You be quiet. 124, right? Our distance was 124. I'm not going to use miles. Like it's miles, but I'm not writing the units in there because it's just not going to fit for my pen. And then what was our rate? How fast was that plane traveling in still air? 350. Okay. What about on the return trip when he had a headwind? He was going slower. What was his distance? Yeah, he only flew 116 miles, but his speed was the same. The speed of the aircraft was the same. It's just that he was going against the wind. So notice in the little notice plane, or in the little note, it says that the plane travels for the same amount of time both ways, because it said it took the same time. You see that? So that means that T1 equals T2. So for the time boxes, we're just going to set it up like this. T equals, remember, D divided by R. So in this box, we're going to put what D divided by R is. Well, D, 124, divided by 350 plus W. And in the second trip with the headwind, our distance, 116, divided by 350 minus W. So what do we know about both those equations? We're going to set them what to each other? Yeah, T1 equals T2. So we're going to set these equal to each other and solve. So I have 124 over 350 plus W is equal to 116 over 350 minus W. We need a common denominator. We need the least common denominator so that we can multiply both sides, or we can cross multiply. Which one do you want to do? Because we don't have a number out on the end. Like we don't have a constant on the end. So can we just set these two together and cross multiply, use that butterfly method that we talked about? You guys remember this on the first day? So this becomes 116 times 350 plus W, which is equal to 124 times 350 minus W. So 116 times 350 is, calculator bunny, go. 40600 plus 116W. I just distributed. Someone take 124 times 350. 43,400 minus 124W. So we're solving. We need to move all the variable terms on one side, all the constants on the other. So are you okay with me doing that all in one step? Yes or no? Okay. So I'm going to add 124W to both sides. And I'm going to subtract 40600 from both sides, minus 40,600. So let's see, 2, 3, this should become 240W equals 0, 0, 34. Is that 28? 2800? Who's my calculator head? Is that right, Jack? Is that what you're raising your hand for? You got that? 43,400. Yes, that's correct. Okay, divide both sides by 240. And what do we get? 11.6 repeating. So, God bless you. So this is, we're finding the wind speed. So the wind speed is about 11.7 miles. It's about 11.7 miles. Okay. God bless you. I think we have one more question to do. One more question. Ma'am. Oh, okay. Sorry. Turn around. He's not your dad. Stop. You distract yourself. Okay. Mackenzie, let me know when you're done, honey. You guys, we're going to do page 15. This is a work type problem. I always found these problems, the one that I love these types of problems, making a table and like solving those. Those are my favorite. But I always found these work problems to be extremely challenging. I don't know why. I just always have. Say again. Here. Can I just spray? You're welcome. Okay. All right. So now we're going to look at another type of problem, and it's about getting a job done. A road crew can pave a section of highway in 12 hours. So the whole crew paves a section of the highway in 12 hours. A second crew working with newer equipment can do the same job in 8 hours. How long? So we're doing the same job. How long would it take to pave the same section of highway if both crews work together? So this is like a brilliant way to think about this. I never thought of this. When I saw these notes, I was like, oh my God, this is so cool. So if it takes 12 hours to complete the whole job, then I can do 1/12 of the job in 1 hour, right? And if it takes 8 hours for the new crew with the better equipment to do the whole job, then they can complete 1/8 of the job in an hour. So working together, they will complete it in some amount of time. I don't know what that time is, but here's what that's going to look like. 1/12 plus 1/8 equals 1/t. And I think that that's super cool. Okay. So when I first did this problem, I said, sometimes my brain gets away with me, and I multiplied both sides. I was looking for my common denominator, and I used 48t. Is that okay? Why? It's not voodoo math. No. There is a lower one. There is a lower common denominator. It's 24t. But is it okay if you can't, like, if your brain messes up and can't find the smallest one and we use 48t, are we going to get the same answer? I think we are, because I got the answer of 4.8 when I multiplied by 48t. Let's go ahead and multiply both sides by 24t. And I just want to show you that it really is okay if you can't find the smallest one, because it's still going to reduce, right? 12 will go into 24 how many times? So I have 2t plus 8 will go into 24 how many times? 3. So 3t. And t over t crosses out, so that leaves me with 24. 2t plus 3t, and when I did it, I got 6t plus 4t equals 48. So this is, we get 5t equals 24, and my work says 10t equals 48. That should be an equal sign. Which one of these is correct? They both are. When you solve, you still find out that the time is going to be 4.8 hours. Okay. 4.8 hours. So now we're going to think about like draining a tub. I think you guys see questions about draining a tank is what it is in your homework. So a bathtub can be filled in 6 minutes, but it takes 8 minutes for the bathtub to drain. If the faucet is turned on, but the drain is accidentally left open, how long will it take to fill the tub? So there's a note over here that says use subtraction when they work against each other. Use subtraction when they work against each other. So if it takes 6 minutes to fill it, then 1/6 is the fraction that I'm going to use to represent that, right? That's the time it's going to take me to fill. Minus, they're working against each other. How am I going to represent this 8 minutes in terms of a fraction? 1/8. And what am I calculating? The total time, 1/t. GCF? Greatest common, or not a GCF, so sorry. LCD, least common denominator. What are we going to multiply both sides by? 24t. Yeah, 24t. Same as we did on the last one. 24t. Does everybody understand how we're cross-reducing, or do I need to write this one out so we can see it? Raise your hand if you'd like me to write it out. Show the math, because I will. So we're multiplying every single thing by 24t. So it looks like this. You don't have to do this if you get it. 24t over 1 times 1/6 minus 24t over 1 times 1/8 equals 24t over 1 times 1/t. So now we're going to cross reduce. 6 will go into 24 4 times. 4 times t times 1 is 4t. 8 will go into 24 3 times. 3 times t times 1 is minus 3t, because that's a negative. T will go into t 1 time. 24 times 1 is 24. So 4t minus 3t is 1t. So the time that it's going to take is 24 minutes. If they're working against each other, it's going to take 24 minutes. What are you thinking about that? I think it's a neat concept, neat activity, and you just have 6 questions for your homework. 6 questions for your homework. So you have page 16 for your homework. I'm going to walk around and help. And we have a journal entry today. 4.4 journal entry is posted. Does it say 4.4 journal entry? Yes, 4.4 journal entry is posted.